Good morning, students. Chapter 6, Work, Energy and Power. In last lecture, we have discussed about what is potential energy. Okay, potential energy means energy or work possessed by object due to its position or due to its configuration. Okay, if due to external force position changes, then yes, potential energy also changes. And in last lecture we have discussed about gravitational potential energy, that is U is equal to mgh. M mass, G gravitational acceleration, and h is height from some reference surface. Okay, now in this lecture we will study about potential energy, but it is elastic potential energy. It is elastic potential energy. See, first of all we will understand what is meaning of elastic. What is meaning of elastic? Elastic means it is elasticity, one property of object. One property of object. Elastic, yes, the word you may have heard. Okay, elastic object means if we apply some external force on object, then due to that force, body is deformed. Deformed means there may be change in length, change in volume, or change in shape. So if external force is applied, body is deformed, and if external force is removed, that object, if regains its original shape and position back, then it is called elastic object. It is called elastic object. Yes, if you have a rubber band, okay, if you stretch rubber band by applying force, and if you release that external force, it will regain its original position, its original shape and size back. So yes, that rubber is elastic object. Okay, so what is elastic object? What is elasticity? Elasticity is property of object due to which it will regain its original shape and size back. Clear about this? So yes, here elasticity is property of object. Elasticity is property of object due to which it regains its original shape, it will regain its original shape or position after removal of external force. Okay, so yes, it is meaning of elasticity, and such objects are called elastic. Actually, there is one difference: elastic and plastic object. Elastic means after removal of external force, they will regain their original shape back. In plastic, after removal of force, they will not regain their original shape and size back. Clear about this? So yes, elasticity means this. Now elastic potential energy. We will take one example of spring and block system. Okay, so consider a system of spring and block system. Consider a system of spring and block. Consider a system of spring and block. See, here it is. It is wall, rigid wall. With this rigid wall, a spring is connected. At free end of spring, one block is connected like this. Okay, and yes, it is on horizontal surface like this. Clear about this? Okay, so yes, as shown in figure, one end of spring is rigidly connected with wall, and another free end is connected with a block of mass and as shown in figure. One end spring, one end of spring is connected, rigidly is connected with rigid wall. Okay, and free end of spring, free end of spring is connected with a block of mass and clear about this? Okay, yes, in this normal situation, and yes, we will restrict the motion of this block only in one dimension, that is, let it is x direction. We will restrict motion of block only in one dimension, that is in x direction. So yes, this block can move only in x direction. So here we will restrict the motion of block only in one dimension. Okay, we will restrict the motion of block only in one direction. The block will move only in x direction. Clear about this? Okay, block will move only in x direction. Now, it is normal condition of block. Normal condition of spring means this spring is not in stretch condition or not compressed. Normal condition means it is not stretched or it is not compressed. Clear about this? Okay, normal condition means there is no extension or compression of spring. So here, as shown in first figure, okay, let in normal condition of spring. Normal condition means without extension or compression. In normal condition of spring without extension or compression, block is at x is equal to 0. This block is at x is equal to 0. Clear about this? So it is called its equilibrium condition, or it is said to be its normal condition. In this case, this spring is not extended or is not compressed. Clear about this? Okay. Now see, now if this block by applying some external force, is displaced in this direction, right hand side, yes or no? Okay, see, like this. If the same block by applying some external force in this direction, is displaced in this direction, like this. Okay, means we have displaced this block by distance x. Okay, if we displaced this block by distance x, okay, as shown in figure, then yes, now this spring is under extension. Means this spring is stretched. Clear about this? Okay, yes, external force F is applied in this direction. So yes, this block will move in this direction. Displacement is in this direction. See, displacement is in this direction. Clear about this? So yes, if block is displaced by distance x, what is change in length of spring? change in length of spring is x. Clear about this? Change in length of spring is x. Okay. Now, if I am applying force, at this point, if I remove external force, what happens? If I remove external force, what happens? Yes, you know that this block is connected with this spring, so this block will now move in this direction to regain its original position back. Clear about this? So yes, if I remove this external force, it is external force. If I remove this external force, then this block will move in this direction. To regain its original position back. Okay, so see here. If block is displaced by applying a pull, if block is displaced by applying a pull by distance x, increase or change in length of spring, is also x. And now if that pull is removed, means this external force is removed. The block will move towards its normal position, to regain its original position back. Clear about this? Okay. If pull is removed, the block will move towards its normal position. Okay, to regain its original back. And the force due to which it regains its original position back is called restoring force. Clear about this? Why it is named restoring force? Because due to this force, this block will regain its original position back. This spring will regain its original position back. Clear about this? So such a force is called restoring force. Okay, so see here what is restoring force? Okay, such force is called restoring force. Okay, which will bring block, or we can say spring, in original condition. Clear about this? So yes, it is meaning of restoring force. Yes, same thing happens when spring is compressed. Okay, if spring is compressed in this direction, means if displacement x is in this direction, then yes, restoring force will act in opposite direction. So see, here it is. There is one relation. This displacement x is in this direction, but restoring force is in opposite direction. And yes, this restoring force depends on displacement. If displacement change in length is more, restoring force is also more. Okay, so now how to relate this? See, here it is. See, now, if here, restoring force is directly proportional to change in length and in opposite direction of change in length. See, from here it is clear. This change in length is in this direction. So restoring force is in opposite direction. What is restoring force? Do you understand that? Okay, what is restoring force? Okay, if I am stretching spring like this, see, displacement is in this direction. So restoring force will act in this direction. Okay, and due to restoring force, it will regain its original shape and size back. Clear about this? Okay, yes. If you have a spring, a small spring, take that small spring between thumb and this finger, and now try to compress that spring. Yes, initially it is compressed easily. Yes or no? Easily. Okay, but if you compress that spring more and more, you will experience a push in opposite direction on your thumb and finger. Yes. Okay, you can perform that experiment. Take one spring and try to compress that spring. Okay. After some time, you will experience some push on your thumb and finger. Okay, yes, on your thumb and finger, the push is acting in opposite direction. So that is nothing but restoring force. Clear about this? If you jump on a spring, then what happens? Yes, initially that spring is compressed, and then due to restoring force, that spring will regain its original shape and size back. Clear about this? So yes, restoring force is directly proportional to change in length and is in opposite direction of change in length. So how to write this? F is proportional to minus x. Why F is proportional to minus x? Restoring force F is directly proportional to x. As change in length increases, restoring force also increases. Why minus sign? Because they are in opposite direction. So if I remove proportionality, I have to add some constant. That is, F is equal to minus kx. Where what is k? K is called spring constant. Okay, that you have to remember. And its value depends on given material. F is proportional to minus x. F is equal to minus kx. K is spring constant. Clear about this? So yes, it is equation of restoring force that you have to remember. F is equal to minus kx. Okay. Now, if I say this block is connected with this spring, or if we have a spring, then will that spring be compressed or extend by itself? Is extension and compression of spring is possible without applying any external force? No, we have to do some work. Why to do work? Yes, here it is, due to restoring force. As gravitational force always pulls the object in downward direction, restoring force always pulls the spring to its normal condition. So if we want to increase, if we want to decrease, if we want to change the length of spring, we have to do some work, and that work is stored as potential energy. So yes, here to change length of spring by x. Okay, work work done against restoring force, against restoring force. W is equal to integration f dx is equal to W is equal to kx dx. Yes, we have to take only magnitude, okay? And we want to change length of spring by x. See, here block is in normal condition. So what is change in length for spring? 0. But here change in length for spring is x. So here it is from 0 to x. Now k constant, so out of integration. So W is equal to k constant. It is x dx. Limit is from 0 to x. So here it is k x square by 2. Limit is from 0 to x. Now put upper limit minus lower limit. Upper limit is x, lower limit is 0. So yes, you will get W is equal to, it is k x square by 2. And yes, this work done is stored. This work done is stored as elastic potential energy, elastic potential energy of spring, Clear about this? So if spring constant is k, change in the length of spring is x, then what is potential energy? What is elastic potential energy? U is equal to half kx square. U is equal to half kx square. Clear about this? Clear about this? So yes, it is all about elastic potential energy of spring. Elastic potential energy of spring. Again, we will repeat this topic. See, a spring and block. Block, it is at x is equal to 0. This spring is not in extension mode or not, it is compressing. So yes, there is no change in length. Okay. Now if this block is displaced in this direction by applying some external force, so yes, displacement is in this direction, means change in length for spring is in this direction. If I remove external force, then we know that this spring will move in this direction due to restoring force. Due to restoring force, the force which tries to move the block, the spring in original condition. Okay, so yes, restoring force is produced in opposite direction. Clear about this? Now, this restoring force is directly proportional to displacement. As displacement increases, restoring force increases. As direction displacement increases, restoring force increases, and they are in opposite direction. So F is proportional to minus x. So F is equal to minus kx, where k is spring constant. Okay, so yes, if I want to displace this block in this direction, I have to do some force against restoring force. I have to do some work against restoring force. Similarly, gravitational force is acting in downward direction. To move block in upward direction, we have to do some work against gravitational force, So similarly here, to change length of spring by x, work done against restoring force. W is equal to f dx, 0 to kx dx, and you will get U is equal to half kx square. Clear about this? So yes, it is all about elastic potential energy. Okay? Okay, now next topic is conservative force, relation between potential energy and force. See, if I say I have a block, and on block, if applying force F, it is displaced by distance delta x, then what is work done? Okay, if due to force F, displacement of object is delta x, then we know that work W is equal to, it is F delta x. Yes or no? We also know work energy theorem. What is work energy theorem? W is equal to delta K, but here W is equal to F dx, so I can write it as F delta x. Equation number 1. Clear about this? Now we know what is law of conservation of mechanical energy. Law of conservation of mechanical energy, law of conservation of mechanical energy, that is kinetic energy plus potential energy is equal to mechanical energy. Law of conservation of mechanical energy, kinetic energy plus potential energy is equal to mechanical energy. If I write this equation for change, then we know that E, that is total kinetic energy, E is always constant. E is always constant, that is summation of kinetic energy and potential energy, that is mechanical energy, is always constant, means always conserved, is always conserved. Okay, so yes, if I want to write this equation in form of change, I can write like this: delta K plus delta U is equal to 0. Change in kinetic energy plus change in potential energy is equal to 0. How? What happens if from this ground I throw some object in upward direction? Throw means initial speed is more, so kinetic energy is also more. Yes or no? Yes. As this block is moving in upward direction, we know that as block moves in upward direction, velocity decreases, so kinetic energy decreases. But height increases, so potential energy increases. Yes or no? If I throw any object in upward direction, then as it is moving in upward direction, its speed decreases, so kinetic energy decreases. K is equal to half mv square. But as h increases, potential energy increases. So yes, see, these two changes are in opposite direction. Okay, and yes, if you calculate, you will get change in kinetic energy is equal to change in potential energy, but opposite nature. But at each and every stage, total energy, that is E, it remains conserved, it is constant. So there is no change in mechanical energy. So yes, K plus U is equal to E, so delta K plus delta U is equal to 0. So delta K, or we can say delta U is equal to minus delta K. Delta U is equal to minus delta K. Now what is value of delta K? It is F delta X. So delta U is equal to minus F delta X. So I can write delta U is equal to minus F delta minus U is equal to minus F delta X upon, or if yes, you make F as subject. From this mean F as subject, then F is equal to this minus delta U upon delta X. Clear about this? Okay, if I am taking displacement very small, that is delta X tends to 0, then I can write this F as F is equal to minus du upon dx. F is equal to minus du upon dx. Means force applied is equal to negative of gradient of potential energy. Gradient means change with respect to distance. So yes, it is for conservative force. Yes, gravitational force is conservative force. For conservative force, F is equal to minus du upon dx. F is equal to minus du upon dx. This equation you have to remember. Okay, for conservative force, F is equal to minus du upon dx. Clear? So, what is meaning of this? If you are given potential energy, then from that potential energy you can easily find what is force. For example, for spring, we know that U is equal to half kx square. Yes or no? If I put this value in this equation, F is equal to minus d upon dx of half kx square. Half k constant out of integration. Okay, then yes, it is d upon dx of x square. What is differentiation of x square? It is minus half k. It is 2x. So this 2 cut, this 2 cut. Then yes, we will get F is equal to minus kx. That is nothing but restoring force. Yes or no? That is nothing but restoring force. Clear about this? So yes, it is relation between force and potential energy. If you are given potential energy, with the help of this equation, you can easily find what is force acting on system. Clear about this? So yes, again, you have to take care about this point. Kinetic energy plus potential energy is equal to mechanical energy, that remains constant. But for change, I can write delta K plus delta U is equal to 0. If change in kinetic energy is 500, then change in potential energy must be minus 500. Minus 500. So the radiation becomes 0. Clear about this change? I am talking about change. Clear about this? So yes, from last 2 lectures, we are discussing about potential energy. We are discussing about potential energy. Clear about this? Yes. If you have any doubt in this topic, okay, then contact me. Okay, we will discuss about that, and I will try to solve your